Okay, so let's start. So today we'll solve mathematics GATE 2023 question from calculus. This is question number 11. So it is what it is saying, let f and g, two functions from R2 to R, they are defined by f of xy is x square minus 3y2 xy square, and gx x comma y is 4x to the power 4 minus 5x square y plus y square for all xy in R2. So consider these two statements. So P statement is saying that P has a saddle point at 0, 0, means at origin, and Q is saying that G has a saddle point at 0, 0. Then we have these four options. We have to check which one is correct. So option number A is both P and Q are true. Option number B is P is false but Q is true. Option number C is P is true but Q is false. Option number D is both P and Q are false. Okay, so let's solve this one. So these are the NPTEL reference. So before solving the question, we need few definition and results. So let's look at this. So first, let f is a function from some open subset of Rn to R, where omega is open set. We say that f has a local maximum at a point a in omega if fx less than equals to fa for all x in some neighborhood of a. Similar for minimum, so we say that f has a local minimum at a point a if fx greater than fa for all x in some neighborhood of a, right? And local maximum and local minima are referred to as local extrema. Moreover, if this inequality means fx less than equals to fa hold for all x in the domain, then we say that f has a global maximum, and if fx greater than equals to fa for all x in a, we say that f has a global minimum, right? Now let's define. So this is we define this is called the gradient of f. Gradient of f at a. This is defined. This is by del f del x1 partial derivative of f with respect. These are n partial derivative. This is vector. Okay. So now let's look at one more definition. So this a point a in omega, where the gradient of f is 0, is called the critical point of f, right? Okay. Now, so this is the critical point. Now let's look at this. This is the definition. This is called the Hessian matrix of a. Hessian matrix, Hessian of a at the point a. So how this is defined? This is the all the partial second partial derivative. The first one a11 component is the del f by del x12, del 2f by del x12, and like this. So in the diagonal, all the del f by means del 2f by del xi as there. In the off diagonal, the mixed partial derivatives are there. So this is called the Hessian of f at a. We also, so let's look at another definition. A critical point a is said to be non-degenerate if the corresponding determinant of the Hessian matrix is non-zero, right? So critical point when there is a gradient of f is 0, and a non-degenerate critical point which is neither local extrema means nor neither local minima or local maxima, we call it a saddle point. Okay. And so for this, when the point is non-degenerate, we have a means result. We have theorem from where we can determine the point is local maxima, local minima, or saddle point. So this is a for n equals to 2. N equals to 2 we can easily check. So let's f is a function from omega, which is subset of R2, open subset of R2 to R. Let be C2 function because we need the partial derivative to exist for at least order product 2. And let a be a point which is non-degenerate. So this is important. The point is non-degenerate. And let alpha is called del 2f by del x2, beta is del 2f by del y, del x del y, gamma is del 2f by del y2. Then if alpha gamma minus beta square is positive and alpha is positive, then f has a local minimum at a. what is option 2 is saying, if alpha gamma minus beta square is positive and alpha is negative, then f has a local maximum at A. And number 3 is saying that if alpha gamma minus beta square is less than 0, then f has a saddle point at A. So what is basically saying that for n equals to 2, if you look at the corresponding Hessian matrix of f at A, so this is look like del 2f by del x2, this is del 2f by del x del y, because this is symmetry matrix, del 2f by del x del y and del 2f by del y2. So it is saying that if this Hessian matrix is positive definite, then f has a local minimum at A. If this is negative definite, then f has a local maximum at A. And if this matrix is indefinite, then f has a saddle point of f at A. Okay. So let's then solve the question number 11. So f is given x square minus 3y2 xy square. So what is okay, f xy is x square minus 3y2 xy square. So we have to check that 0 0 is a saddle point or not. So let's check at first find the partial derivative of f with respect to x. So what is del f del x? It will be 2x minus 3y2 y square, right? And what is del f del y? It will be minus 3xy, right? So let's find the gradient of f at the point 0 0. So it will be del f del x at the point 0 0 and del f del y at the point 0 0, right? So if you put it here, you will get both 0 0. So gradient of it at the point 0 0 is 0 vector, so which implies 0 0 is a critical point of A, right? So now we have to find the Hessian matrix to say that this critical point is non-degenerate or degenerate. So let's find the Hessian matrix. So for that we need the second partial derivative. So find del f del x2. So it will be 2, right? What will be del 2f by del y2? It will be minus 3x. And the mixed partial derivative, because these are C2 functions, they are same, del 2f del y2 del x del y, del 2f del y del x, both will be same, and it will be, so it will be minus 3y, right? So then what will be the Hessian matrix? H of it. So at the point, suppose first xy point at general point, it will be del 2f, or so it will be del 2f by del x2 means 2. It will be minus 3y minus 3y minus 3x, right? So Hessian matrix at the point 0 0, it will be 2 0 0 0, right? So what will be the determinant? Determinant of h of at the point 0 0, it is 0, right? So as the determinant is 0, which implies 0 0 is degenerate critical point, right? Degenerate critical point. So as 0 0 is degenerate critical point, so we cannot use this theorem, right? Because this is applicable for non-degenerate critical point. So for degenerate critical point, we have to examine the function, means we have to go by definition. We have to examine the function in a neighborhood of 0 0, right? So let's look at this. So for non-degenerate critical point, so what is fxy? Remember fxy is x square minus 3y2 xy square, right? So you have to analyze this function in a neighborhood of 0 0. So let's write it like this. Take half x by 2 common. So then it will be 2x minus 3y square. So we have factored it out, and note that f of 0 0 at the point 0 0 the function takes the value 0. So now note that this has a two factor, right? One is x, one is 2x minus 3y square. So along the, you can see that along this parabola 2x equals to 3y square, this function is 0. So if we take this parabola on this, suppose x equals to, if you take y square, then what will happen? Then f of y square comma y square will be half y square, and if you put x equals to y square, you will get minus y square, right? So this is basically minus 1 by 2 y to the power 4, which is strictly less than 0, strictly less than 0 if y is not 0, right? So in a neighborhood of 0, along this curve x equals to y square, if y is very close to 0 0, this function is 0, less than 0, right? And you can easily check that if you take this curve along on x equals to 2y square, then what will happen? Then f of 2y square comma y, so it will be half 2y square, this will be y square, right? So this is y to the power 4. So this is strictly positive if y is non-zero, right? So we see that if you take y as close to 0, so in a neighborhood of 0, this function takes both the value in a arbitrary close to 0 0, right? So this function changes is not uniform. It means as f 0 0 is 0 0, but in a neighborhood it takes both value, greater than 0, less than 0. So 0 0 is not a local maximum or minimum. So from here we can conclude that 0 0 is a saddle point of A. Saddle point of F, right? So for F we have done it. So now we have to do it for G similarly. So F has a saddle point at 0 0. So P is correct, right? Now let's check for G. So what is G? G is 4x to the power 4 minus 5x square y plus y square. So now G x y. So this is the similar. So let's do it. Minus 5x square y plus y square. Again we have to check the 0 0 is critical point or not. So let's find del g del x. So del g del x will be, if you differentiate with respect to x of g, we will get 16x cube minus 10xy. Del g del y, so you will get minus 5x square plus 2y. And let's find the all other partial derivative del g by del x2. So it will be 48x square minus 10y. Del 2g by del y2, it is 2, and del 2g by del x del y, which is same as del 2g by del y del x, which is minus 10x. So let's check what is gradient of g at the point 0 0. So del g del x at 0 0 at 0, and del g del y also 0 0, so it is 0 0, which implies 0 0 is critical point. Of G. Now we have to check it is non-degenerate or degenerate. So let's find HF Hessian matrix at 0 0. So what it will be? It will be del 2gx by del x2 at the point 0 0. So it will be 0, and it will be minus 8 0 0 2. So we'll get this is the Hessian matrix at 0 0. Then what will be the determinant? So this is again 0, which implies, so 0 0 is degenerate critical point. So again we cannot use the theorem to conclude that 0 0 is a saddle point or not. So we have to again go by definition. So let's analyze the function g in a neighborhood of 0 0. So what is gxy? Gxy is 4x to the power 4 minus 5x square y plus y square. So let's factor it out. If you factor it out, you can see that this is looks like 4x square minus y into x square minus y, right? And again g of 0 0 is 0. So again, by looking at these two factor, we take these two curve. We first take y equals to 3x square. So what will happen along this curve? Then gx 3x square, it will be x square times minus 2x square. So it is minus 2x to the power 4, which is strictly less than 0 if x not equals to 0, right? And take the another curve when this will be positive. So take y equals to half x square. Then g of x half x square, what it will be? So if you check, it will be 7 by 4 x to the power 4. So which is positive if x not equals to 0. So again we see that at g of 0 0 is 0, and on a neighborhood, if you take x is non-zero and very close to 0, then this function changes value. Along this curve, it y equals to 3x square, it takes the value less than 0, and along y equals to half x square, it takes the value y equals to is greater than 0. So as it is changes sign, which says that 0 0 is a saddle point of G. So both the points are saddle point of F and G. So what we have got, that G has a saddle point at 0 0. So this is also correct. So which options are correct? Both P and Q are true. So option A is correct and all other options are false. Okay. So let's stop. Okay, bye.